You guys are hardcore. I'm not going to lie. I am very tired right now. This is day 2. You guys are hardcore. I just took some random powder from somebody's bag. Thank you for that, by the way. I'm kidding. It was like electrolyte drinks. All right. Hello, everyone. My name is Joyce. I'm here from San Francisco. I'm jet lagged. I'm tired. This is my dog, Lucy, right there. A little hard to see. For the last 7 years, I worked at Postman. How many people have heard of Postman? Okay, you guys. Okay, so Postman is an API developer platform used by over 30 million developers. I was an early employee, and I was there for about 7 years building out the developer relations department. How many people know what DevRel is? Okay, so not that many people. If you're not selling to developers or developers are not using what you're making, you probably have never heard of developer relations. But you'll notice that a lot of the speakers yesterday and today will have developer advocate or developer relations titles. And it's typically a job that's focused on external developers, helping enable external developers use your own technology. But today I'm going to talk about some lessons of how you can take those DevRel learnings and apply it to your own teams. So I spent a long time in tech at Postman, 7 years. That's like a huge time, right? About 6 months ago, I started a new job at VM. It's a super early stage robotics and robotics startup working with physical devices. And it was a big change, moving from APIs to robotics, moving from software to hardware. It was a big deal for me, but I was like, oh, how hard could it be, right? Developers are all the same. Okay, so whether you agree or not, we'll take a look at examples of how and when we should treat developers all the same or differently. Again, we'll talk about lessons learned from DevRel. And then, just because I wanted to keep things interesting, lessons learned from deployment disasters. That's my favorite part. Okay, again, just think about this all in the context of how you're working within your own team, within your own organization. So let's start with some developer marketing wisdom, what you want to hear on day 2. So one of the first things a traditional marketer learns is you can't market to developers, or you might have heard you can't sell to developers. Who has heard this before? Okay, so like a quarter of you. So this is not true. You absolutely can market to developers and you can sell to them. It's big business. But what do people mean? Developers are a skeptical audience. They're smarter than your average consumer. At least they're more savvy. They know how the sausage is made, so they're a little bit more skeptical. Traditional marketers always say, talk about the benefits, not the features. For developers, it's the exact opposite, right? No, tell us the features. And in fact, tell us how it's done. And this is why a lot of developers will look at docs instead of a marketing webpage to see, what is this tech? Well, how would I use it? Developers as a group are these special snowflakes, but they're also not a monolithic group. So developer relations, sometimes it rolls up to marketing, sometimes it rolls up to product or engineering. An early DevRel lesson, when you first put on your DevRel boots, is that developers are not all the same. Who has heard this before? Okay, 3 hands. So what that means is within the developers group, there are differences. You're not going to be talking to a DevOps engineer the same way you talk to a web dev, okay? They're going to be using different languages, frameworks, terminology, and mostly they have different goals. So they're going to have different workflows and how they get work done. And that doesn't mean that one is better or more technical, but you're just going to communicate to them differently. You can either do it generically and broadly and lump everyone together, or you're going to be very targeted and specific. So let's look at an example. A few months ago, told you started a new job. VM hosted a meetup in their robotics lab in New York City. So we were like, okay, who's going to show up? We were like, pins and needles. So VM is software, but it's specifically designed to run on all different types of physical devices. So we thought the people that might show up might be software engineers, maybe hardware engineers. So we asked them when they registered, what is your job function? How do you identify? But we left it open-ended. And it turns out that the people who showed up could be grouped into a few different areas. Some groups overlap, like robotics and hardware, overlappy. Some groups are far apart. Data and hardware engineers far apart. And we look closer, we saw differences between the groups. Data has data science, scientists, engineers, analysts. They all do different things. But data people, they write Python. Software developers, they write Python, same, right? But maybe one is using VS Code, maybe another is using Jupyter Notebooks. Another way to look at this is Stack Overflow surveyed 65,000 developers saying, what do you spend most of your time doing? Can you see that back there? Probably not. So at the top, most people are full stack, back end, front end, right? But then there's a huge long tail. There's DevOps specialists. It's 1.7%, very small. SRE engineer down here, is 0.5%. Even further down on the tiny part of the tail is developer experience engineer, right? That's 0.4%. How many people have literally SRE in their job title? Okay, more than I thought. There's 10 or 15 hands there. And even if you don't identify as an SRE, everyone here is here at an SRE conference and they're doing SRE work and they want to learn more about it. So when do we treat developers like they're all the same and when do we not? Who's heard of pets versus cattle? Okay, half of you. Amazing. So it's a popular server analogy. When you treat a server as a pet, it's unique, might get a special name, and it's indispensable. That means when it goes down, it's hand-fed and receives special care. With this approach, it's not really horizontally scalable and reliable, which is why you can also treat your servers like cattle. Each server is standardized, it gets a number, it's designed with failure in mind. So if it struggles, no one's nursing it back to health. It gets taken out bat, shot, replaced, usually automatically. So treating servers as cattle makes it easier to scale out and plan for reliability. Here's a relevant XKCD. Probably can't see that. Guy on the left, we need to make 500 holes in that wall, so I've built this automatic drill. It uses elegant precision gears to continually adjust its torque and speed as needed. Guy on the right, great. It's the perfect weight. We'll load 500 of them into this cannon we made and shoot them all at the wall. Right? So modern cloud infrastructure lets us treat servers like cattle, but whether you choose, there's no right answer all the time. There's always a trade-off. So how can we apply this analogy to developers? When developers are individuals like little pets, each person on a team might have specific skills and strengths, which means that you might need special tools and workflows for the team to be fully effective. Just like with servers, having specialists on the team is not really efficient for scaling out and standardizing. When developers are treated the same like cattle, you try to standardize your workflows, tooling, your roles. You're hiring generalists, and they're interchangeable within a team. Now you can scale out and you have better reliability. And when one suffers, you take it out back. Just jokes. But trade-offs, right? Innovation and sometimes job satisfaction goes down when you treat developers like this. Both models have their trade-offs. When do we treat developers like pets? And when do we treat them like cattle? I'm so thirsty right now. I wish I had water. Oh my God, no, sorry, no, please sit. Oh my gosh, I really need water. Okay, when do we treat developers like pets and when do we treat them like cattle? I just realized that's on the audio too because they are recording audio. Excellent. All right, so sometimes it depends on the maturity of your organization, right? This is the life cycle of an organization. For early stage, you can imagine that developers are doing a little bit of everything. With a growth company, you scale or you die. So you're going to try to standardize that and try to scale everything. Mature companies, you probably have developers working on these specific microservices. Oh, my sweet Mother Mary, thank you. Now you have to listen to you. So at each stage, imagine in your mind's eye, you've intuitively know this already, but how much autonomy, speed, and innovation do you think a developer has? Are they prototyping? Are they optimizing? Are they scaling? Are they cutting costs? When should you hire your first SRE, and when do you build out an entire SRE function? So how you view developers is not just about job title, not just about DevOps engineer, web dev, right? It's not just about the name on the team, SRE is a function, or the stage of the organization, but it's the sum of it all. So why is this important? Why am I talking about this? It impacts your hiring strategy. How you view this impacts your approach to developer onboarding, and you can think about it on how it allows you to influence change. So for hiring, I said, are you hiring generalists or specialists, right? Is it important for you to hire people that have the skills already, or are transferable skills a good proxy for how well they'll do? Do they need direct experience, or can you train them up? For developer onboarding, how do new engineers on your team get started? What's the technical onboarding process? Do you have broad documentation already because you've been around and now you have specific guides for use cases? Are you publishing templates for other people to follow? Do you have prescribed golden paths? And how do new engineers ask questions? What support do they have in the first 30, 60, 90 days? I've heard of companies that have 30-day classroom cohorts, right? They hold your hand, they spoon feed everything. Others are sink or swim, or they call it self-serve, right? Very scalable. And then your communication methods. How do you communicate? How do you share information? And how do you innovate? something I heard about recently. I haven't tried it yet. I'm curious if other people have done it. One way to share information with a team is called mob programming. Has anybody done this ensemble programming? Okay, so 5 hands. That's more than I would have imagined. So with mob programming, you have one driver, right? It's like pair programming, but more expensive. So you have one driver. They can't make any decisions. Everyone else are the people that navigate. They ask questions. They make decisions. So it is very expensive. Why would you do this? It might be worth an experiment. Maybe you take 2 hours on a Friday afternoon, get everyone together and try this mob programming method. It's very effective at sharing information. And even more importantly, it's how you can influence cultural shift within an organization. So we'll talk about this a little bit later on. But if you're trying to implement change, it usually doesn't stick unless there's a little bit of societal pressure. And this is a really good way to share that culture and that context. So it's really good within the team to impact change. But across teams, not so much. Not this one, at least. So to influence change across teams, between teams, let's look at some organizational design principles, starting with Conway's law, right? So organizations which design systems constrain or produce designs which are copies of the communication structures of their organizations. It's like an old-timey picture. This is back in 1967, right? But it's been around for a while. Here's an example. Geographical boundaries, right? This is the U.S. map. So you have clumps of developers in different areas. There are also socio-technical boundaries. Again, Conway's law, paraphrased, your communication structure determines your technical structure. And if your organization is notoriously siloed, what you produce is going to be notoriously siloed. So what can you do about it besides demanding that people return to the office and then you share that communication real hard? To counteract the Conway's law, you have the inverse Conway maneuver. This says you have full control over this. Change the communication patterns of the designers to encourage the desired software architecture. The most popular example of this in action is when you're implementing microservices. Small independent teams allow you to decouple into microservices architecture, whereas a single large team results in a monolithic architecture. This is the reason, one of the reasons why we have reorganizations, right? It's why DevOps actually succeeded, right? You're trying to bridge the communication paths to align incentives. I forgot I left this slide in here. But the Postman CEO actually said it like this. He said, teams are like APIs. When there's failures in communication, you just need to iron out the interface, right? Postman, API company, he viewed literal teams when they weren't achieving what they needed to do, iron out the interface. But this is really tough. This kind of governance, again, without the social norms and the societal pressure, like enforcing it. So we'll talk about that in a little bit. Oh, fun part. Okay, I'll fly through this. I'm looking at the timer. All right, fun part, deployment disasters. So we talked about developers as pets. Now let's talk about them as cattle, just looking at some juicy deployment disasters and seeing what we can learn from developers. So this is MKBHD. This is popular YouTuber. He wanted to review an electric car from Fisker. But they asked him, oh, hold on, we know there's some issues, right? Wait for the V2 release. They even wanted to send out a field tech with a USB drive and deploy that latest software update. But he's like, no, let me just review what's on the market, what's in production, what people have actually paid money for. And it ended up being a really bad review. And at the same time, no coincidence, but the Fisker valuation just tanked. So eventually, Fisker released V2 over the air, right? Fleet rollout. The lesson learned here is that over the air gives you more control and speed in deployments. Another disaster. Google Nest pushed a huge update to their users in the middle of winter, leaving people without heat. They didn't think about, oh, what happens if residential connectivity drops in the middle of an update? Lesson learned, don't ignore network and device constraints. Make your updates small, make them resumable, so that when inevitably you get connection again, you don't have to start over from scratch. Facebook, massive global infrastructure outage. This one was with their network backbone. None of their data centers could talk to each other, which means logging and monitoring didn't work, right? Which means it's hard to figure out what the issue is. And engineers were physically locked out of data centers, which doesn't allow them to diagnose either. So lesson learned, logging and monitoring needs to occur across large distributed systems. Build in redundancy with your hardware, right? If your communication with your hardware fails, what's the fallback? And I heard that a crowbar is what they use to get into the data centers. Deployment disaster. Last year, Rivian another electric car company, pushed an OTA update that locked up the entire infotainment system. The actual build was tested for months on actual production vehicles, but during deployment, an engineer selected the link for the wrong security certificate, right? And the impact to the whole fleet was only 3% because it was a canary rollout. Good and bad. They originally thought that a physical repair would be needed, again, sending out field technicians, recalling the cars, but eventually found a way to issue an OTA update to a part-loaded device. Very creative. So even with extensive testing, it's still human error that sent the wrong build out. And then this part I thought was rather juicy. So Rivian didn't have a playbook for how they let customers know what was happening. So this is their head of software on Reddit, our Rivian, saying, hey guys, here's what's happening, right? And public relations didn't find out about it until the next day when they sent out emails. Oh, have you heard of this one? So this is the closest this is the closest we've ever gotten to Y2K. This affected over 8 million systems, estimated 10 billion in financial damages. And when you dig into the root cause, there's a ton of actual reasons why this happened, but testing basics were missed, right? CrowdStrike ex-employees. Quality control is not part of our process. Hilarious. But lessons learned. Did they have tests? Sure. But tests are only as good as you write them. You can also canary test. This is what Rivian did, which is why they only hurt 3% of their fleet. Canary test before rolling out to the entire fleet. Or implement blue-green deployments so that you don't have to wait for a fix. You can just roll back to an older active version. And dual boot systems for folks that are dealing with firmware updates. So one last bonus example. I just added this last minute because I saw a bunch of people in suits outside wearing Patagonia vests. And I'm like, is this a financial district? So Schwab is a large bank that acquired TD Ameritrade. TD Ameritrade's not in the UK, I don't believe, but both very big banks. Big acquisition, took 4 years to complete all the little steps. And on the last weekend of their 4-year deadline, they migrated robo-traders doing algorithmic trading on the TD Ameritrade API over to the Schwab API, right? They waited until the last weekend, and when the markets open on Monday, you would send your first API call and get 429 too many requests. Yeah. So if the TD Ameritrade engineers didn't know that the API traffic was being proxied through a CDN, they didn't configure the proper headers, then every API call is coming through from the same IP. Okay, so lots of lessons learned. I won't go over all of them, but TLDR, stuff happens. What can you optimize for? This is a Rumsfeld awareness understanding matrix. Sounds really important, but break it down into the known unknowns, right? In that quadrant, our goal here is observability. There are known tasks that you can manage with monitoring and SLOs. Known knowns, this is really hard to say. Known knowns. For known knowns, the goal is to automate predictable tasks. Unknown knowns, root cause analysis with postmortems to put your guardrails in place. And then the unknown unknowns, this is what we saw with Facebook. For unknown unknowns, you build resiliency to recover from less predictable failures more quickly. So stuff happens and we can try to influence change. But this is the iron law of oligarchy, right? Organizations are naturally ruled by a few loud voices. So on your own team, who are those loud voices? Who make the actual decisions? Who influence change the most? Teams are not democratically run. It's not a consensus. And that means that it's hard to make lasting change. Without external pressures in place, change just tends to revert back to what it was before. This is why governance isn't as easy as creating the tools, explaining the why, getting people on board. Changes don't stick without those social norms to pressure it into that new shape. And that's why mob programming is good, because you can actually influence the culture and the context. Another learning, life finds a way. We saw this with CrowdStrike and Rivian. User testing is chaos testing. Tests are only as good as you write them. And you can create your templates and run books to automate and reduce your risk. And you can create playbooks to help with incident response. But our attention spans are limited. We're limited right here. Resources, attention, time, all of this is limited. You start with your North Star. Is it going to be quality? Is it going to be performance? Is it going to be availability? It can't be all of them. You can't do everything, at least not all at once. If you're starting a new team, you're starting from scratch, you start with the broadest common denominator, and then you start narrowing down and getting more specialized as you gain resources. So takeaways here. Developers really are not a monolith. Our core challenges and desires are fundamentally the same, and part of our jobs as teammates is to help bridge those gaps and create more cohesive and collaborative environments. Thank you for letting me go first. I'm sweating right now a little bit, but if you want to talk to me about deploying the physical machines, if you want to build a confetti cannon for your next team meeting to affect that change, please do come say hello. Thank you very much.